Good afternoon, everyone.
Good afternoon.
We are the members of Team Dalton, and today we are going to present you on the following topic. My name is Daniel Chidama, and with me are Asma Bahago, Mutawali Ahmed, Isaac Anjuma, and Ibrahim Tuku.
The properties of suspension. One, we have the...
Can you be audible enough so that we can hear what you're saying?
The properties of suspension. We have one, the particles are larger than 10 raised to the power minus 6 meters. It is a heterogeneous mixture. The particles in a suspension do not pass through filter paper, so the suspension can be separated by filtration.
Although most particles are soluble in most substances are soluble in water, some are more soluble than the others. That is, their solubility differs. So solubility is a means of comparing the extent in which different solids can dissolve in a solvent.
While dispersion can be defined as when the dispersed particles in the colloids cannot be separated through the medium, which is filtration. However, they can be coagulated or precipitated by solutions that have metal ions in them. Thank you.
So one of the effects of temperature or solubility is that an increase in temperature leads to decrease or increase in solubility.
In temperature, depends on whether...
No, you said, I want to capture the points. You said increase in temperature leads to, is it decrease or increase in solubility of a substance in solvent?
In temperature, increase in temperature leads to decrease.
Decrease in solubility, increase in temperature leads to decrease in solubility.
Increase in temperature leads to increase in solubility.
Alright, so why the increase in solubility as a result of increase in temperature?
The higher the temperature, the more easy the solute dissolves in the solvent.
Okay, what will make the solute dissolve faster as a result of increase in temperature? That is what we want to know.
The heat.
What happened? Yeah, of course, the temperature is the heat supply, isn't it? So, the more the heat, the more solubility occur. Why? How? Can you use kinetic theory to explain what is happening? And it's using the kinetic theory of matter. How can you explain that happening? When I increase heat, solubility of a solute increases. How can I explain further using kinetic theory?
The kinetic theory of matter states that energy cannot be transmitted, cannot be destroyed, but can only be converted from one form to another. So when there is an increase in the temperature, the solvents will dissolve faster in the solute because of the heat.
solvent will dissolve the solute faster, or the solvent will dissolve in solute?
The solvent will dissolve in the solute faster.
Okay. What will make the solute dissolve fast? That is the point. Do you understand my question? From kinetic theory, an increase in temperature leads to an increase in the what? Average kinetic energy of the molecules present in the solute. And by the time the average kinetic energy of the solute increases as a result of increase in temperature, the intermolecular force of attraction becomes weaker, thereby separating the molecules that were closely packed together in that solute. And by the time that force of intermolecular attraction is weakened, what happens? The molecules tend to be independent. And by the time they become independent, the solvent can easily penetrate through individual molecules and make them become what? Vulnerable, thereby making the dissolution or solubility of that solute to be what? Faster. That is what I want you to mention based on kinetic theory. Is that okay? Alright. The last question. You made mention of pressure. Increase in pressure leads to what? How does it affect solubility? The higher the pressure, the higher the solubility, isn't it?
Yes, sir.
The mass per unit volume of the solute, for example, if we are talking of gas, isn't it? When you compress a gas at high pressure, alright, in the process of dissolving that gas in what? Solvent. Let's say, for example, water. Let's say you are dealing with hydrochloric gas. You want that gas to dissolve to give you aqueous solution of hydrochloric acid. You increase the pressure of that gas. Increasing the pressure will bring the gas molecules together, compressed, thereby dissolving in water quickly, and what? Solubility becomes high. But if you lower the pressure of the gas, there tends to be higher what? Intermolecular spaces between the molecules. The molecules could not be brought together when the pressure is lower. So that will hinder what? Solubility. So the solubility will be lower. It will not be fast as expected. Is that understood? Alright, thank you. You may have your name.